My name's Jeff Morin. I work for Amber on TrustWave, and I'm the senior security consultant there. I'm in a group called Spider Labs, which is our pen test technical group there. And today we're going to be talking about type conversion errors. And it's probably a term that you haven't heard before, and it's kind of something that we tried to put a term around because it's something that we haven't really run into in the past, and it's something that's kind of popped up recently. And so we thought we'd do a little presentation about it, let everyone else know kind of what we've been seeing, and because of kind of the impact of some of the things that we've been seeing, we wanted to let everyone know to be checking for those type of things. So, a little background. Everyone's very familiar with data types and what you can set a variable to. Just kind of wanted to cover though that an integer, if you have a 1 and you have a 0, 1, those both evaluate to the same value. When you're manipulating data like that, to the computer it's still 1. Same thing if you prepend 100 zeros to a 2, it still evaluates to a 2. Same thing with a float. 1.0 is the same as 1.00000. Same thing as prepending 0, 0, 0, 0. That doesn't work the same way with strings, though. Strings are what you see is what you get. The same thing if you prepend a 0 to a 1, it doesn't evaluate the same as just a 1. So it's a little background kind of with what we're going to be talking about. And basically what we're going to be talking about is how user input, when it's sent into a web application, if it's processed in different areas of the application as different data types, you kind of run into problems there. And we'll get more specifics then, but that's just kind of the background. So the vulnerability, the problem that we've been seeing. So in web applications, you take user input and you set it as a certain data type. And a lot of times, if it's a number, you're going to set it as an int or a float. It's pretty logical. Everyone's pretty familiar with this. So we've seen that with a number of applications, data, like the core code is, built so that, the proper data type is used for the proper format of data that's being input. You put in an int, you save it as an int, you store it in the back end as an integer, and, it's processed that way. We've also seen, though, maybe with add-on third-party products, additional functionality is built into an application, and with that additional functionality, this data is then processed not as an integer or a float, but might be processed as a string. And when you process something that could evaluate, like we had talked about before with the 0001, evaluating to a 1, but then if you process that as a string, they don't evaluate to the same value. And so that disconnect, that gap right there, is where we've been seeing issues. And we're going to have an example to explain this because it's a little bit confusing when I explain it like that. But basically, when you're using different data types for the same data, and that disconnect will can cause a breakdown in functionality. And especially if that functionality is of a security nature, if you're making sure that certain individuals can't do certain actions based on a security function you have, and I'll explain later, then that's a bad thing. If you're going to be breaking security functionality by being able to manipulate user input and then having it, obviously break that, then that's bad. So let me kind of give you an example so you kind of understand what I'm talking about. You have a web application, an e-commerce site, which has a shopping cart. And the shopping cart, you can put items in, seen it a million times, saves the items, it saves that information, and when you start putting items in there, it creates an integer, it creates a value that says, that uniquely identifies this shopping cart, this order basically, and, it's a long integer. You keep putting items in there, you keep, taking them out, whatever. Then you want to go and you check out. So you check out, you pay for your items, it goes and it gets processed. And your order is good to go. That data is saved in the back end, and it's linked to, it's identified by that integer. Additionally, though, that data then, that integer, is also written into a string array. And that string array is basically a list of blacklisted items where the order's been processed and you can't go back and you can't make any additional changes. So once you do this purchasing, once you complete your order, and this integer value is then written into the string array, you're not allowed to go back and make any changes. Now, going back to what we talked about before, with that gap between integers and floats being processed one way or being evaluated to one value and strings the other way, an attacker, and we've actually seen this happen, could go and then prepend a 0 to this ID. And I've actually got a flowchart for that, but could prepend a 0 to this ID. It would go through, it would be looked up correctly, but then when it went to look into that string array to say, am I able to process this order, am I able to make changes to it, it would fail. And by failing in that security functionality, that string array, it allows an attacker to then go and make changes to their order. And it kind of goes back to the whole, hidden fields where you can make changes, buy things for $1, buy things for free, a penny or something like that. You could go through and you could just start removing items. Your order's already gone through and been processed, and it's going to be shipped out. But you could add additional items to that. And it says you've already paid for one item, and all of a sudden your order's been updated. When it's going to be shipped, they look at the list of all the items that you purchased, and all of a sudden you have 10 items. So we've seen that, for e-commerce sites. We've also seen it for additional functionality, and I'll just kind of go through the process flow. So like what I just said before, the process is you submit an order, and it's looked up in the back end, parsed for the blacklist, and goes through correctly. And then the opposite is that, it goes through, looks up in the back end, verifies that it's a valid product or valid order, and then fails the blacklisted string array. And then ultimately you can make changes to the order. Additionally, we've seen this with other functionality where if you want to restrict a user from doing certain things, or you want to restrict certain users from doing certain things, we've seen an easy way to do it is to create an array and just toss in unique identifiers there, which are of numeric nature. But then when you do this type of thing, when you prepend a 0, or if it's a float, if you add a .0 or .000 or something like that, all of a sudden you have additional functionality which you didn't realize that you're going to have. And because of that, we don't see many or any tools that automatically check for this type of thing. It's very hard because you don't know what functionality could ultimately result from prepending a 0, or changing the value so it evaluates correctly for integers or float data types, and then fails for strings. Because we do a lot of black box testing, you don't know what's back there. So, these days when we go through and we check for web applications, we go through, check the entire thing, we identify where all of the potential integers, potential floats, those type of data is being input, and we'll go and modify all of that. But additionally, we'll parse through the entire site once we modify that, because you don't know if this stuff is going to pop up. If all of a sudden you're going to have additional functionality in a password change area where you didn't before, or any of the user profile stuff or things like that. So it's tough to identify because it's not like SQL injection where you're going to get ODBC error messages popping back to you. It's just kind of something you have to manually parse through, and that's kind of what we've been doing recently to identify these type of things. And once you start looking for that, once you kind of have in the back of your mind that if I prepend a 0, or if I added .000 or something like that, when you just start modifying this stuff, these things will start popping up. So that's kind of what we've been seeing, examples. And does anyone have any questions about that type of stuff? I mean, it's pretty straightforward once you hear about it and once it's explained that way. But if you don't think about it and you haven't seen that happen, it really wouldn't occur that maybe people are writing IDs into string arrays, and maybe that they're dealing with the data types differently, and maybe that's something that we should be looking for when the assumption is, people set the data types correctly, and you're always using a backend, you're always evaluating the same data. So if anyone doesn't have any questions, we'll be walking around, and definitely ask me if you have anything. Thanks.